talk a little bit more about even and odd functions and building on what we did last time. Now let's just suppose that we have a function f of x. Okay. Now to review what we talked about last time, the function f of x is even. Let me draw my x and y axes. F of x is even if the function is symmetric across the y-axis. Okay, here's the y-axis, here's the x-axis. So if the function is symmetric this way across this axis here, then we say the function is even. So for example, y equals x squared equals x squared is an even function because it looks something like this, and it's symmetric across this. If the function is symmetric across across quadrants, in other words, if it's symmetric this way and this way, then we say the function is odd. Okay, remember that? So let's suppose we have any function, and that function f of x is neither even or odd. Suppose I take, okay, so I'm given f of x. Now suppose I take 2 times f of x. And so I can write that as f of x plus f of x. Okay. Now, it's 2 times f of x. Now, suppose I add and subtract f of negative x to both sides. So I'll take 2 times f of x is equal to, now here's what I'm going to do. I'm going to take f of x plus f of x, and now I'm going to take plus f of negative of x, like that, minus f of negative of x. Now, since I've added here and subtracted the same thing, I haven't changed the value of the expression. Now let me rearrange terms. Let's take these 2 terms and put them together, and let's take these 2 terms and put them together. So I'm going to rearrange my terms, and when I do that, I get this is equal to f of x plus f of negative of x and then these 2 terms, the other 2 terms, let me put become f of x minus f of negative of x. So the negative sign goes with that term, and the positive sign goes with this term. Okay? So I've taken the sum of these 4 terms, rearranged them. And let me put parentheses around. So I have parentheses around this and parentheses around this. Now what I want to do is I want to look at these 2 expressions separately. I want to look at this expression and I want to look at this expression. So let's look at f of x plus f of negative of x. So I want to look at f of x plus f of negative of x. Let me call this sum let me just call it g of x. This should be g of x. Okay? So let me ask the question of you, is g of x itself going to be a positive, is it going to be an even function or an odd function? So in other words, what's the relationship between g of x and g of negative of x? What is that relationship? Okay, now go back over here. Okay, g of x is equal to f of x plus f of negative of x. So everywhere where there's an x, let me replace it by a negative of x, so that this f here becomes f of negative of x plus this negative of x. Now a negative of x becomes a positive of x, and this is g of negative of x, of negative x, negative of x, negative x. So if I take this expression and I replace x by negative x, there, I have f of negative x plus f of positive x equals g of negative x. However, this is exactly the same thing. This is equal to g of x. This was our definition of g of x. So we have that g of x is equal to g of negative x. So this now implies that g of x equals g of negative x. That means our function g of x is even. Okay, g of x is even. Let's look at that other function we had. The other function, which I'll call h of x, was equal to f of x minus f of minus x, or f of negative x. This. Now, what's the relationship between hx and h negative x? In other words, what's this relationship? Well, let's see if we do what we did last time, and everywhere where there's an x, we replace it by negative of x, and then negative of negative x becomes a plus. So this becomes h of negative x is negative f of x equals negative of f of x plus f of negative x. Now, by the definition of h, this is just equal to negative of f of x minus f of minus x. Now, by the definition of h, this is equal to negative h of x. So here's what we have, that h of negative x is equal to negative h of x. This means that h of x is odd. Okay, now let's summarize what we have just shown. we said that if we start with any function f of x, we multiply it by 2, that's equal to f of x plus f of negative x plus f of x minus f of negative x. I'm going to put brackets around this and brackets around this. And I said that this function right here is what we call g of x. And this function right here is what we called h of x. So we said that g of x is even and h of x was odd. And this is just 2 times f of x here. Remember, this is a 2 times f of x. Okay, so I can say then, the following is true. That any function f of x can be written as multiply through by a half both sides. So this is 2f of x. So multiplying by a half is the same thing as dividing this by 2. And dividing this, and this is equal to this also divided by 2 plus this divided by 2. So any function f of x, these cancel, is equal to g of x divided by 2, or 1/2 times g of x, plus h of x divided by 2, where g of x is even, so this whole thing is even, and h of x is odd, so this whole thing is odd. So this is even, and this is odd. So any function f of x can be written as the sum of an even function plus an odd function. F of x can be written as the sum of an even function and an odd function, where the even function is given by g of x over 2, where this is g of x, and the odd function is given by h of x over 2, where this right here is h of x. Okay, this is parentheses here. This is h of x. Okay, so this is how you now compute those even and odd components. But this is a very interesting and useful result, that any function can be written as a sum of an even function and an odd function. Okay? So, any function f of x can be written as the sum equals the sum of an even function plus an odd function. Okay, now with that, I think I should assign you some homework problems to look at to see if you can compute what those even and odd functions happen to be. So let's go back And let's look at our graphing calculator right here that we looked at previously. In particular, let's look at this function, right, which we said was neither even nor odd. It's equal to this function plotted in red is equal to the absolute value of x minus x cubed. Okay, so let me write that out. Y, here's our function, f of x is equal to absolute value of x plus x cubed. Well, right off the bat, maybe right off the bat, you recognize an absolute value of x is an even function. And that x cubed is an odd function. Okay, let's check that. Go back over here. Let me add a function here, add new equation right here. ABS absolute value of x. Now let's plot that. Okay. So here's absolute value of x. Is this function symmetric across the y-axis? I think it pretty obviously is. And absolute value of, let's add another function here. Let's put x cubed there, and let's plot that. Here's x cubed. And this function is symmetric across here, and it's also symmetric across here, but there's no values of the function, so it's trivially symmetric across there. So we have the function which is given by the difference between these two, which is this function right here, right there, and we could write the function which is given by the sum of those two, which is the one I have just plotted out. This is the sum of absolute value of x plus x cubed. So let's plot out what that is. Absolute value of x plus x cubed, new equation, okay, ABS x plus x cubed, plot it, and there it is right there. So this function right here is given as the sum of an even function plus an odd function. So that's an example. Okay, we can try doing some more examples in the classroom.